Section 3 of Chapter 7, we're still factoring polynomials. We're attempting to get boringly good at our method here. We're going to ask the same two things every time and go from there. So there's no guesswork here. In 7.3, it'll be very similar to 7.2, but in 7.3, the lead coefficient, that a value, is not going to be 1 anymore. So if you were successful with 7.2, either because you were doing what we were doing, converting the 3 terms to 4 terms, or you had your own method, you'll find that 7.3 employs that same thing, only now you've got an a value of not equal to 1. It's been my experience that students who do the guess and test kind of method that the book was recommending for 7.2, sometimes 7.3 becomes a little bit more difficult. So you may want to try what we're doing here, see if that helps you. And of course this can work for all of them, all the different types of factoring. So let's just go through this one more time, the steps that we're going to do all the time, and we covered this in 7.1a. We're going to check for the GCF. We're always going to check for it first. And every once in a while I slip up and forget to check for it first. We want to make a good habit of it. Always check for a GCF, something it has in common, all the way first. The next thing we're going to do is we're going to ask how many terms. Now if the GCF is pulled out, we just ask how many terms are left over. If there's no GCF, we look at the whole thing, how many terms. Because there's only 3 options that we're going to look at, 2 terms, 3 terms, or 4 terms. And in 7.4, what we called 7.4 most, we looked at how you deal with 2 terms. And if it's factorable, it's one of 3 special forms, and really 2 patterns that you need to learn. Difference of squares is one of the patterns, and then the pattern for cubes, it's the same pattern for either difference of cubes or sum of cubes. And there is no formula for sum of squares. That one cannot be factored, and anything that doesn't fit either of these categories cannot be factored as well. Then we jump to 4 terms, and that was the second part of 7.1, 7.1b, and we looked at, to deal with that, we're going to do factoring by grouping. And then finally, in section 7.2, and now continuing in 7.3, which is what we're doing right now, we're looking at 3 terms. And our method is going to be to convert those 3 terms back to 4 terms so that we can use factoring by grouping. So, and let's recall one more time, what is factoring? Well, factoring in its most basic definition is you're undoing the multiplication, the distribution, the foiling. Okay, so we're undoing the foiling or the multiplication or the distribution. You'll notice the distribution feel to it as you pull out a GCF. It's the undoing of that distribution. The foiling is really what we're looking at undoing right now, because we are converting from the 3 terms to 4 terms. And in fact, that is the goal of going from 3 to 4 terms, is we're going to split the like terms that combined, the oi piece, the outside, inside of the FOIL that ended up being like terms and combined into 1 term. We're going to split that oi piece back into its original outside times outside and inside times inside pieces. And we call that the strategic split. And we have some steps at the bottom of the page, which we'll look at again when we do the examples. And so we want to recall what a standard form of a trinomial is. This is key to being able to do these steps to find the strategic split. Standard form of a trinomial is you put the x squared piece first. So the ax squared plus bx plus c. So the c is the constant, the x term is in the middle, and the x squared piece comes first. And we are interested in the coefficients a, b, and c for this method.